Hey guys, welcome back to another video. In this video, we're going to be solving a few vector sums. Right, so starting off with question 1, with respect to origin O, the points A, B and C, Dn are given OA, OB, OC and OD. Right, so what they want to know is the obtuse angle between vectors OA and OB. Right, so if I draw a small sketch over here, just to get the reference of where the points are. So OB is over here. This is the position vector of B. This is the position vector of A. Great. So if we know that, now we can try and find out the angle in between. And the moment they ask us to find out the angle, we jump off to the dot product formula, right? Which is saying A dot B is equals to modulus of A and B times cos theta, right? So this angle is actually an obtuse angle greater than 90 degrees. So first of all, let's find out the dot product, which is 3 times 1 plus minus 1 times 2 minus 2 plus 2 times minus 3, which is minus 6, and the summation is minus 5. Great. On the right hand side, the modulus of A is basically root over the square of all of these, right? So 9 plus 1 plus 4, 3 square plus 1 square plus 2 square times the modulus of B, which is 1 square plus 2 square plus 3 square minus 3 square, and the value we get after multiplying both of this is 14. So cos theta turns out to be minus 5 by 14. This is your cos theta value. So they're saying that cos theta is negative, right? Where is cos theta negative? Over here and over here on the second and third quadrant. Great. So for this, the base angle, if you use your calculator and find the theta, the base angle that you get is 69.1. This is not your theta, this is your base angle. So since cos theta is negative, your theta is going to be this entire angle, and to find that, you subtract 69.1 from 180, right? The value that you get is 110.9. This is your value. This is your theta, obtuse angle between OA and OB, right? What are they saying next? The line L passes through points A and B, right? This red line, it is passing through A and B. What are they saying next? Find a vector equation for the line L. They're asking you to find the vector equation for the line L. Great. The easy way to do that is, first of all, what you need to do is find out AB. Find out AB, the vector AB, the direction vector AB. Great. How do you do that? AB is basically AO plus OB. And AO, you can write it as minus OA since the direction is reversed. Great. So minus OA plus OB. So what you get is this vector plus this vector. And if you add it up, AB turns out to be minus 2, 3, minus 5. Great. So now getting to the vector equation, granted, this is the point you're starting from, A. This is the value or the constant or the variable, whatever you want to call it. This is basically how far you've gotten from point A. This is your direction, and mu1 is going to denote how far you've gotten from point A. Mu1 could be 1 or 1000 or infinity. You don't know the value of mu1. Mu1 is basically telling you how far along this direction R1 has gone. So basically, if you have a point over here and the vector is telling you that it's going 2 units in I direction or X direction, and it's going 1 unit in Y direction. So in this case, this is the vector direction, and you say that the vector is 2i plus 1j, and let's say A, in this case, in this case is origin. So it's starting from the origin. So 0 plus mu times the vector 2i plus j. This is the vector equation. So in this case, let's say the vector was to be elongated and was this much. In this case, this has traveled a greater distance. In this case, mu could be 2.5. Since the vector direction has not changed, but the magnitude has changed. So what is mu denoting? Mu is denoting the magnitude of the vector. Great. So if you understand that, this is how we have created the vector equation. Granted, we are starting from this point, which is 3 minus 1 and 2, which is that point. This. So you're starting from this point. And the magnitude is mu1, which could be any value. And the direction is -2, +3, -5. How did we get that? The AB direction. The AB direction is going to give you the vector direction. Great. This is how you form the equation. Nice. So what are they asking next? Find the position vector of the point of intersection of the line L and the line passing through C and D. Right. Find the position vector of the point of intersection of line L and line passing through C and D. Great. So C and D is basically these 2 points. They're asking that the line is going to intersect through this C and D line. Right. So basically, if you turn this longer, and you'll notice that at some point the line AB does indeed intersect with this line. So basically they're asking you, when do they intersect? To find that out, there are a few steps. First of all, we have to find out this, the direction CD, the vector direction CD. How do we do that? To find CD, what we're going to do is make CD the subject, where CD is given by the difference between OD and OC. Since OC plus CD is actually OD, right? So if you know that, you make CD the subject, and now you have the vector for CD, which if you take these values and add them up, subtract them, you're going to get most likely 4 minus 4 and 6. So you can add them for yourself, and subtract them for yourself, and you're going to get OD 5 minus 1 minus 6 plus 2 and 11 minus 5. This is going to give you 4 minus 4 and 6. So this is again your direction, this is your magnitude, and this is your starting point. In this case, the starting point is C. Right. So yeah, this is your vector equation. Nice. Next up, what do we do? We're basically going to compare this part of the equation with this part of the equation. So this entire equation is for AB, right? This is AB vector equation. And where did it go? This is your CD vector equation. And they're telling you in the question that both AB and CD are going to intersect. Therefore, since this part of the equation represents the x coordinate, and this part of the equation represents your x coordinate as well for different equations. But if they intersect, these two coordinates are going to be equal. The x coordinate for both of these are going to be equal. Let's say this was AB and this was CD. This point, at this point, all of their coordinates are going to be the exact same. This is why we can say 3 minus 2u, 3 minus 2i, so minus 2u, this magnitude mu, 2 mu. 3 minus 2 mu is exactly the same as 1 plus 4 lambda. Great. So you do the same for all of those, and eventually you're going to get the values for both mu and lambda. So basically you compare the x coordinates, then you compare the, this is minus 1 plus 3, so yeah, then you compare the y coordinates, and in this case only comparing the x and y is going to be, as if you solve them simultaneously, you're going to get the values for mu and lambda, right? So put these values in your calculator and solve them simultaneously, and you get the value for mu and lambda. Once you know that, it's very simple, and you basically plug this value in over here. You plug the value in over there, and you basically 3i minus j plus 2k plus, let's say mu is minus 3, so minus 3 times minus 2i plus 3j minus 5k. You simplify this entire thing and you get the coordinate. This is going to be your coordinate for the point of intersection. Great. So that is your question 1. Alright, question 2. Relative to the origin O, the points A, B and C have position vectors given by OA, OB and OC. Great. The quadrilateral ABCD is a parallelogram. Find the position vector of D. Right. So you know the points A, B and C, but what you don't know is the position vector for D, and they want you to figure out the position vector for D. Great. To do that, you know, the vectors AB and DC are equal. Why are they equal? Because they are in the same direction. This is a parallelogram, and in parallelograms this and this are going to be equal, so their vectors are going to be equal. This and this are going to be equal, so their vectors are going to be equal. Great. So if we break these vectors down in simple terms, so AB is going to be OB minus OA to get AB, and on the right hand side, if you break DC down, DC is going to be OC minus OD to get DC. Great. Now, since you have everything in terms of the position vectors, you can find OD. So OD turns out to be 1, minus 4 and 3. You basically simplify this and you get 1, minus 4 and minus 3. Great. So now we can move on to question B. The angle between BA and BC is theta. Angle between BA and BC is theta. Great. Find the exact value of cos theta. Nice. So whenever they ask you about the theta, you simply move off to the dot product, nothing else. Right, the dot product, in this case, let's see. A dot B is equals to the magnitude of A and B cos theta. Right. So for that, you need to figure out a few vectors, which is, in this case, since they want to know the angle over here, you need to find out BA for one thing, and you also need to find out BC. Great. So to find that out, let's break down BA and BC. BA is basically OA minus OB, and you're going to get BA, right? So on the other hand, we have BC, which is going to be given by OC minus OB, right? So if you understand that, you basically plug in the values and you get the vectors, which is relatively simple. Right. So after putting all the values, and getting the vectors for BA and BC, you now have A and B. So plug those in and find the scalar product, which is going to be -2 times -1, which is 2, plus -2 times -5, which is +10, 1 times -6, which is -6, and this is going to be equal to the product of both the modulus times cos theta. Right, so the modulus of BA is going to be the root of all the squared values. Where is it? Right, BA, right, this. So -2 square plus -2 square plus 1, which is going to be 4 plus 4, 8 plus 9. It's going to be 9. And you have 25 plus 36 plus 1, which is going to be most likely 25 plus 36 plus 1, 62. Right, 62. Then you root those values and make cos theta the subject, and what you get is this. That is your cos theta value. Nice. So what are they asking next? They're asking you, after finding the exact value of cos theta, hence find the area of ABCD, giving your answer in the form P root Q, where P and Q are integers. Great. So find area ABCD. Find area ABCD. Now, what is ABCD? It's basically a sum of two triangles. This is one triangle, and this is, my friend, another triangle. Great. So if you know that, you basically just have to multiply the area of one triangle with 2, and you'll get the area of the parallelogram. So how do you find out the area of one of those triangles? You know BA, you know BC, you also know theta. You don't need anything else. So basically you use half AB sine theta and you're going to get your triangle area. So the area of the parallelogram is 2 times the area of the triangle. So 2 times half of AB sine theta. What is A? A is basically, where did it go? BA, which is 3. Root of 9 is going to be 3, of course. So 3 times this, root of 62, and sine theta. This is a bit of a twist. So basically for sine theta, you know the cos theta is 2 by 62. So draw a triangle, adjacent by hypotenuse, and this is your height or opposite side. How do you find that? Use Pythagoras theorem, and you're going to find that your height or the opposite side is 58. So what is sine theta? Sine theta is oppo by hypo, and this is your sine theta value. So you simply plug this in. Great. So that is how you get the area. If you simplify, you're going to get 3 times root 58. Nice. So that is your question 2. Let's quickly move on to question 3. Great. So question 3, the points A, B have position vectors I plus 2j minus 2k and 2i minus j plus k respectively. The line L has equation this. If you remember, I already told you, this is your starting point, this is your magnitude, this is your direction. Great. So they've told you one vector equation for line L. They've given you the vector equation. Great. So question A, what are they asking you? Show that L does not intersect the line passing through A and B. Show that L does not intersect the line passing through A and B. So your first job is to find the line equation for A and B. How do you do that? First of all, you find out AB, because you need the vector AB. So break down AB into minus OA plus OB, and you're going to get the vector 1, minus 3 and 3. Nice. If you do that, you know the vector, which is this. You also know the magnitude. You just give a random variable, mu, t, whatever you want. And this is your starting point. What is your starting point? Your starting point is basically A. you can take any B or A as your starting point, doesn't matter. In the MS you might see that sometimes the answer has a minus over here. Basically they've taken another point as the starting point, so there may be a bit of a difference, but your main answer will never be different, as in the values for, not this, your values for, where did it go, if it intersects or not. And then sometimes they're going to ask you the value for constants, for example, later on. So yeah, these values are not going to be affected, but your equation might look a bit different because they're considering different points as a starting point. So it does not matter, don't get confused. Right, so coming back to this question, you have your starting point, magnitude, and your vector. Nice. So what you do over here is compare the x, y, and z coordinates of both the equations. So look at the equation that is given and look at the equation that you have just found out. You compare the x, y, and z coordinates. So how do you do that? You basically take the x coordinate over here, which is this, which is basically what, 1 plus lambda, 1 plus lambda, and the x coordinate over here, which is 1 plus 2 mu, 1 plus 2 mu, right, 1 plus 2 mu. You do the same for the y coordinate, and these two will be enough to give you the value for mu and lambda. Nice. So if you use your calculator, you basically plug in the values and solve them simultaneously, and you're going to get the values for mu and lambda, which is going to be 1 or 2. Nice. So what do you do next? You do bring in the third equation, which is for k, or the z height or z axis, whatever you want to call it. And over here, after you've figured out the mu and lambda, you're going to plug these values in over here. So lambda over here, mu over here. Why? Because if they do intersect, the value on these two sides are going to be equal. If they are not equal, they are not intersecting. Therefore, this is your method for checking if they intersect or not. Nice. So if you know that, you plug in the values and you get 4 on this side and 11 on that side, which are not equal. If both of the values were 4, or both of the values were 11, or both of the values were same, then they would be intersecting and the answer would be wrong. But yeah, in this case the answer matched and A is correct. So next we can move on to question B, which is asking, find the position vector of the foot of the perpendicular from A to L. What is your foot? The foot is basically the line. The line is basically this is L. The yellow line is the L, right? The one they have given you. They've given you an L. So then you basically draw the line for A to the line, to the foot of the line. Basically they're telling you that the line that A is going to be making with this L line is going to be perpendicular. Right. So what did they ask? Oh, they're asking for the position vector. They are asking for the position vector at the foot of the perpendicular line. Right. So they're asking for this P, which is at the foot. Right. So what you're going to do is, first of all, you know the line equation. Now you also need to understand and know the equation for AP. You're going to try and figure out the equation for AP. Great. So first of all, whenever they're giving you this, perpendicular situations, you always know that the dot product of AP and PL is going to be 0. Why? Because A dot B is A mod times B mod times cos theta. But if the theta is 90, remember cos 90 is actually 0. Check that in your calculator. So A dot B, this entire thing becomes 0. So A dot B is 0. So we're going to apply that knowledge over here, and basically we know two vectors. I mean, we know one vector and the other is going to be in terms of a, b and c, because p, we are considering the vector p to be a, b and c because we don't know the vector of p. We're going to be figuring the vector of p, right? So we know one of the vectors, which is 2 minus 3 and 4, which is this. The vector of the line is already given to you. The vector of the line is already given to you. The direction of the line is given to you. In that case, you directly plug in one of the vectors which is known to you, the line. What is not known to you is the vector PA. But you can find out PA. How do you find that out? Basically, you subtract vector A from vector P. That is how you find out the vector for PA. Right. So if you want the breakdown for this, basically OP is OA plus AP. And since we want AP, we are going to make that the subject. AP is OP minus OA. Right. So we are subtracting OP minus OA, which is known to us as well. So what is OA? OA is given above. Where is it? This is your OA. 1 plus 2 minus 2. 1 plus 2 minus 2. So you subtract and the signs get reversed. And that is your dot product equation. That is your dot product equation. Now, the interesting thing is you can represent all these variables, A, B, and C, in terms of mu. How do you do that? So where's the equation for the line? The line is, where's the line? Right. So I'll directly show it over here. So this is your line equation, right? Since that is your line equation, you know that P lies on the line. OP actually lies on the line. So if I write it again, 1 minus 1 and 3, this is your starting point, and I'll move this, right? So mu 2 minus 3, 4, great. So now the interesting thing over here is, see that OP actually lies on the line of L, that is already given to you. So A is actually, if you represent OP as A, B and C, it is going to be equal to 1 minus 1, 3 plus mu times 2 minus 3 and 4. If you're confused about how I formed this equation, I'll explain again. Basically, OP is a coordinate that lies on the yellow line, this line. Since OP does lie on the yellow line, we know that the coordinates of OP will be given by this equation. It will be given by this equation. For a certain value of mu, you will get the coordinates for OP. You don't know the value for mu at which OP is given, so you keep the mu as it is, and you find the x coordinate, y coordinate and z coordinate of OP in terms of mu, because for a certain value of mu, OP will be given by this equation. Great. If you understand that, let's apply that knowledge and write A, B and C in terms of mu. Right. If I do that, now I plug all of these values in over here and I form a pretty interesting equation. Okay, now since I have all of that, I simplify 1 minus 1 minus 1 minus 2 and 3 plus 2, 5. Great. So now what we do is find the dot product as usual. How do we find that? 2 times 2 mu and for mu, minus 3 times minus 3 mu, and you simplify, which is 1 is 9, the other is plus 9 mu, and then 4 times 5 plus 4 mu, 20 plus 16 mu is equals to 0. You make mu the subject and you get mu is equals to minus 1. Right. After you do that, you can plug the value for mu in where? Over here. And finally, you know the value of mu at which OP lies on this line. Great. You now plug in that value and you'll get A is minus 1, B is 2, and C is minus 1. So this is your OP. Nice. So that is your question 3. Right. Question 4. The lines L and M have equations. L is the equation for L is R is equals to AI plus 3J plus BK plus lambda times Ci minus 2J plus 4K. And for M, the equation is R is equals to I plus 2J plus 3K plus mu times 2I minus 3J plus K. Right. Both of these equations are given to you, vector equations, and they're given relative to the origin O. The position vector of the point P is 4I plus 7J minus 2K. Nice. So the question A is given that L is perpendicular to M. Right. So important information. L is perpendicular to the line M. Nice. So if that is the case, you instantly have to use the dot product equation. Okay, what are they saying next is, and that P lies on L. So P lies where? On L. On the line L. Great. Find the values of the constants A, B, and C. Nice. So they want you to know, they want to know where A, B, and C is. I mean, what the constants A, B, and C is. So what you're going to do is, it's a pretty horrid equation. It consists of all A, B, and C. So very simply, the first thing as I said, is the dot product of the line L and the line M is going to be 0. So you can apply that knowledge, and for the dot product you get the scalar product of the vectors. What is the vector for L? This is the vector C minus 2 plus 4. C minus 2 plus 4. And what is the vector for M? 2 minus 3 plus K. 2 minus 3 plus K. So you write that over here and find the scalar product, which is 2C plus 6 plus 4. And you make C the subject and you get your first winner, which is C. So you already secured 1 mark, which is the value for C. Nice. So next you have to find out A and B as well. Interesting. So again, since OP, the line P, and with respect to origin O, which is over here, the point OP lies on the equation L, as seen before with the other question, that since this point actually lies on the equation L, you can say this point is equals to this equation which is given by this, the L equation. Since it lies on L, you can say OP is a point given by the equation L, because for a certain value of lambda you will get the position vector for OP. Right. So you can write this equation in this form, and now compare all of the parts. So for this, first of all, your job is to find out lambda. You have to find out lambda, and you're going to take the middle part, or the J, because there are no constants over there. And you can easily find out lambda, which is minus 2. 7 is equals to 3 minus 2 lambda. So lambda is minus 2. Then what you do is go for the A or B, either of them. So 4 is equals to A minus 5. Actually, this is minus 5 times minus 2. So it becomes 10. Y minus 5 because of this, and y minus 2 because of this, the lambda value. So yeah, you get A is equals to minus 6. You do the same for B and you get B is equals to 6. Nice. So you have answered question A. Full marks. Great. So next, what you do is you solve question B, which is pretty long. Right. So for question B, what you do is they're asking you the perpendicular from P. The perpendicular from P, basically this line, I guess, meets line M. Right. This line, basically the line L, meets M at Q. This yellow dot is Q. The point R lies on PQ. The point R lies on PQ over here. Lies on PQ extended. So if you extend PQ this much, you're going to get R. With PQ is to QR is 2 is to 3. So the ratio is given. The ratio is given. PQ is to QR is 2 is to 3. Great. So you know the ratio. Now they're asking you to find the position vector of R. Interesting. So how do you find the position vector of R? There are a few informations given. So the position vector of R, it's basically over here. So you need to know OP, you need to know PQ to get the position vector for OR. Right, so let's go step by step. First of all, we are going to be finding OQ. Where is OQ? OQ is over here. Right, so we have to find OQ. How do we find OQ? If we get back, basically it is the point where both of the lines meet, and this makes it much easier to find the point Q. Interesting. So since both the lines M and L meet at Q, notice you're going to equate both of the vector equations together and find 3 equations. One for X, one for Y, one for Z. So these are both of your equations, and you're going to compare this and this, then this and this. So basically take all the values and compare. Right. So minus 6 minus 5 is equals to 1 plus 2. You do the same for all these 3, for I coordinate, for J coordinate, for K coordinate, all of them. Right. And you have 3 equations. So from here on, what you do is you basically use 2 equations and you find mu. Very simple. Use your calculator and solve them simultaneously, and you're going to get mu. Interesting. So after you do that, you're going to plug in the value of mu directly to any of the, not any of the equation, the equation that consists of mu. So this equation, you plug in mu and you're going to get the coordinate for OQ. So great. So now you have OQ. So they've given you a ratio, which is PQ is to QR is 2 is to 3. Let's use that ratio. So we can write 3 PQ if we make it the subject. Basically PQ by QR is equals to 2 by 3. Make 3 PQ the subject and you have 3 PQ is equals to 2 QR. Great. So now you can do 3 times. You break down PQ, which is OQ minus OP. PQ, which is OQ minus OP. You can simplify it further down and write the vectors, and you're going to see that PQ can be written as OQ minus OP and QR can be written as OR minus OQ. Great. After you do that, you're going to make OR the subject. You're going to make OR the subject. You take 2 on this side and make OR the subject. After you do that, you solve it, and you're going to get this coordinate. You know OQ and OP, which is given above. So if you do know that, you can find out OR. You can find out OR. Right, so this is your OR coordinate. So that is your question 4. Okay, so we basically used the ratio and broke down the vectors and found out OR, since OQ and OP are both already figured out. Great. So if we know that, next we can move on to question 5. Question 5, what are they telling you? The points A and B have position vectors 2i plus j plus k and I minus 2j plus 2k respectively. So this is your A and this is your B. The line L has a vector equation r is equals to I plus 2j plus 2j minus 3k plus mu times I minus 3j minus 2k. So that is your equation for L. This is your equation for L. Great. So first question is, they're asking you to find the vector equation for the line through A and B. Very simple. You find the vector AB and take a starting point and you write the equation. So vector AB, you break down AB into minus OA plus OB, and then you sum the vectors up and you're going to get this is AB, and you directly put that in over here, the direction, and you take the starting point, any, doesn't matter. I'm taking A as the starting point and I form the equation. Great. Next up, what are they asking you? Find the acute angle between the direction AB and L. AB and L. Find the acute angle between direction of AB and L, giving your answer in degrees. Great. So you know the direction. Do you know the direction? So since they asked you to find the angle, don't worry, directly go to the dot product equation. So this is your dot product, A dot B, which is basically in this case, since this is your vector for the line equation, this is your vector for AB. So this is one of the vector, the other vector is above over here, 1 minus 3 minus 2. That is one of your vector, and this is another vector. This is for L and this is for AB. Right, so you're dotting AB times L. Right, so what is the vector for AB? Minus 1 minus 3 plus 1. Right, and then you multiply or find the scalar product of that with this vector, which is the vector for L. Multiply both of them, find the scalar product, and that is going to be this. That is your scalar product. On the right hand side, you have 2 of the moduluses multiplied. Do that. So basically mod of AB, which is this, you root the square of all of the values, and you do the same for this as well. You root the square of all of the coordinates, and you get root 11 and root 14 times cos theta. Cos theta you don't know, find out theta, and theta is going to be 61.1. So that is your value for theta. Nice. So next up, see what are they telling you? Show that the line A and B does not intersect the line L. Great. So again, intersection. It is basically simultaneously solving all the equations. It's a bit tedious, but yeah, let's do it. AB is equals to, this is the equation for AB, is equals to this. This is the equation for the vector equation for AB, and this is L, and this is the vector equation for L. Nice. So basically, they're asking you if they intersect or not. And the moment they ask you this, you compare their x coordinates, y coordinates, and z coordinates. You compare their x, y, and z coordinates. So find that out. 2 plus lambda minus 1. Yeah, so 2 minus lambda. Compare it with what? 1 plus mu. And do the same for both of these. So you have 3 beautiful equations. Voila. Right. So what you do is solve, and you're going to get lambda is equals to 1 by 3. Plug 1 by 3 into any of the equation, absolutely any of the equation, and you're going to see the values on both the sides are not going to be equal. Doesn't matter which equation you take. For one, it might just add up, so it's rather better to show all of the equations. And I guess in the mark scheme they're asking you to show for all the equations, because in certain cases the lines may be skewed, meaning in one axis they might not be colliding or having the same coordinate, but in other coordinates they might be having in other axes they might be having the same coordinates. In those cases they are called skewed. So it's better to show all the equations where if the values are equal or not on either side of the equation. I've only done for one, and luckily I got it as unequal, so I kept it as it is. Right, but I would suggest show it for all of them, and even if it does not show in only one equation, meaning if the values are not equal in only one equation, that is enough to prove that the lines don't intersect. For intersecting, all of the coordinates need to be equal, all of them. Just one, just two is not enough. Great, if you know that, that is our question 5.